Hello, today we're going to prove that there are infinitely many primes. We're going to do that with a contradiction. So first of all, we need to make an assumption. Our assumption then, like quite often, is going to be the opposite of this. We're going to assume that there's finitely many primes. So a fixed number of them. We can label these primes then. We'll call them prime number 1, prime number 2, prime number 3, etc., all the way up until the last prime number n. So therefore there's n primes in total. Now then, what we're going to do is we're going to imagine a new number. So we're going to let this new number q, we'll call it q. Could be anything, doesn't matter if it's q or p or x or z, or any other letter you like. And we're going to imagine that this number then is equal to the product of all the primes. So prime number 1 multiplied by prime number 2 multiplied by prime number 3, all the way up until prime number n, the last prime. And then we're going to take that and we're going to add 1 to it. We do this so that now let's have a look at dividing this number q by any of the primes in the list. When we do that, we can see, well, it would divide off here quite nicely, but we're always going to have this plus 1. This plus 1 over here is going to be our remainder. So we can say that any prime at all, so prime number I, which could be any number in our list, does not divide our number q. It has a remainder 1. So therefore, we can think, well, if q doesn't have any factors that are primes, either we've missed off a prime number, or q itself must be prime. Either way from this, we know that this fixed number of primes that we had here is not the complete list of primes. So therefore, we have a contradiction. And when we have a contradiction, what that means is our assumption was wrong. So this implies then that there are infinitely many primes.